Alright, this is example 5. I should have written it down before the video started. Example 5, inverse Laplace transform. Now, just a quick tip before I start the video, make sure that whenever you're doing an inverse Laplace transform, your 5s and your s's look very different. Because I can't tell you how many times, I've accidentally, oh my gosh, I actually just spat on the paper then. So yeah. I've actually, when I've been doing inverse Laplace transforms and I've been taking out multiplicative factors, like a scalar, for example, I've had a 5s, for example, in my inverse Laplace transform, and I wanted to take out, or 47s, or something like that. I took the s out the front, because I thought it was a 5, you know? I would have said, 47, 5, so I thought it was 475. And I took that out the front of the inverse Laplace because I thought the s was a 5. So that, long story short, make sure that you make that look a lot different to this. I know I don't exactly make the best example, but just take it from me, you'll be a lot better off. So we'll take the inverse Laplace transform of s squared plus s plus 3 all over s plus 1 s plus 2 squared. So I already know straight away I have to do partial fractions. So s squared plus s plus 3 is equal to s plus 2 squared plus b s plus 1 s plus 2 plus c s plus 1. That's just standard partial fractions technique. So now, let's let s equal clever values. So s equals minus 2. So 4 minus 2 is 2 plus 3 is 5. So 5 is equal to 0, 0 minus c. So c is equal to minus 5. Straight away, I know my answer. So now, let's let s equal minus 1. So bye-bye. Now 1 minus 1, that's 0, so 3 is equal to, I'm going to do it over here to, use paper space, save the trees. 3 is equal to a times 1 squared, so a is equal to 3 straight away. Now let's let s equal 0, because I can't actually solve for b by picking a clever value, so I just let s equal 0. So 3 is equal to, well, I know a is 3, so 3 times 2 squared. Yep. 3 times 2 squared plus b times 1 times 2 plus c, but c is minus 5, and then that's times 1. So 3 is equal to 3 times 4 is 12, plus 2b minus 5. So that's 7, and then 3 minus 7 is minus 4 is equal to 2b. Sorry, that came off the page. I should be watching the page more often. That means b is equal to minus 4 over 2, which is equal to minus 2. Now I can solve my inverse Laplace transform. It's pretty relatively straightforward from here. So the Laplace transform, well, the inverse, sorry, of s squared plus s plus 3 all over s plus 1, s plus 2 squared is equal to the inverse Laplace transform of a, and a is 3 over s plus 1, and then it's going to be minus 2 times the inverse Laplace transform. I just took the 2 out the front straight away of 1 over s plus 2. And then that's plus c, but c is minus 5, so that's minus 5 multiplied by the inverse Laplace transform of 1 over s plus 2 squared. So that's what it, so basically it's split into a series of inverse Laplaces. So now I know that this is, I can take this 3 out the front, and then that's 3e to the minus t. And this is minus 2e to the minus 2t. And this is minus 5, so bye, these are the answers right here. And now the minus 5 is going to be relating to this inverse Laplace transform. Just a reminder, the inverse Laplace of 1 over s minus a is equal to e to the at. So that's where I've gotten this formula from, like where I'm getting these answers from. But because my a is positive in these examples, I know that I have a negative exponent. That's how I remember it. So minus 5, and this is s plus 2 all squared. So this is a combination of, because see how it's similar to this one? So you know it's a combination of e to the at, but it's also a combination of t to the n, because it's got an exponential. So this is going to be e to the minus 2t. I already know that because of the s plus 2. And 2 can be rewritten as 1 plus 1. And if you remember that the inverse Laplace transform, the formula for t to the n is n factorial over s to the n plus 1. And because I know that n is 1, 1 factorial is 1, 1 divided by 1 is 1, so I know that this is just going to be minus 5 e to the minus 2t multiplied by just t, because t to the 1, n is 1. So the answer is, the final answer is 3e to the minus t minus 2e to the minus 2t minus 5e to the minus 2t times t. That's it. So pretty easy example, but they're gonna, again, as I've said, I'm going to build them up. I'm gonna show like all the different tricks of the trade, you know. Biggest tip, partial fractions is literally in every single inverse Laplace transform example. So you really need to, you know, have the endurance. You need to be able to like run a marathon, because these, you know what, doing inverse Laplace transforms, you really just want to apply the rules and you want to have fun and you want to solve the example, but part of solving the example is also doing the crappy part, and that part is solving for the constant coefficients, namely a, b, and c in this example. It's not the funnest thing to do, but it's a part of pretty much every single example, so get used to them and get good at them, and understand not just how to apply picking clever values, but you also need to know how to do the inverse Laplace transform by writing every single variable out and then equating like s squared to s squared terms, s what to the power 1 to the s to the power 1 terms. Like if you wanted to do it that way, you could do it that way, but it takes longer in this case. But sometimes you can't always pick clever values, and sometimes picking clever values is going to take just as much time as rewriting the equations, because you might have 5, 6, 7 variables. Sometimes you could even use Kramer's rule if you wanted to solve for like 3 variables, for instance. But anyway, that's my 2 cents. So yeah, I'm going to be making more examples. Stay tuned.